Okay, so for today's video, we're going to talk about operations with fractions. The operations we're going to be working with are going to be multiplication, division, addition, and subtraction. We're going to start with multiplying fractions and dividing fractions, since a lot of times we consider them to be the easiest. And then we'll move into adding and subtracting fractions, which can actually take a little bit more steps and can be more involved. But for right now, we'll start with multiplication. And so in order to multiply fractions, we will have an example. So to multiply fractions, we can start by simplifying the fractions individually or cross-canceling and then multiplying the numerator and denominator. So let me show you what we're talking about. So if I have my example here, I'll have 6 over 13 times 5 over 14. Now, when we have multiplication of fractions, we multiply the numerator with the numerator and the denominator with the denominator. And so we would be left with 6 times 5 gets us to 30. And then 13 times 14, I know, what was that? 14 times 14 is 196, so a little bit less than that is 182, I believe. I believe 13 times 14 is 182, but let's double check. So if I have 13 times 14, and I'm going to be multiplying these two. 4 times 3 is 2, carry the 1. 4 times 1 is 4, plus 5 is 52, add the 0. I have 130. Yes, it is 182. I'm going to go ahead and erase this extra multiplication because it's just going to take up space for me. But it's good to always double check your numbers. So that's one way we can multiply fractions, and we'll get 30 over 182. However, this is not simplified. And then after this, we would have to simplify this giant fraction. Another way we can multiply fractions is we can use a concept called cross-canceling. I'm going to use the exact same two examples here. I'm going to draw an orange line to separate my work. We will have 6 over 13 times 5 over 14. And instead, what I'm going to do here is I'm going to write down the prime factorization of the numbers that I have in my fractions, the numerators and the denominators. So 6 can be written as 2 times 3. 13 is a prime number, so I'm just going to keep it as 13. If you want to, you could write it as 13 times 1, but that's just going to be extra steps. 5 is also prime, so I'm just going to leave it as 5. But 14 I can write as 2 times 7. And so now, I note that in my numerator, I have a 2, and in the denominator of my second fraction, I also have a 2. Since one is in the top and one is in the bottom, I can cancel them out. And so then that means my multiplication becomes 3 over 13 times 5 over 7. And so our number gets a little bit simpler. On the top, we are left with 15, and 13 times 7 is 91. And after that, I believe that is simplified. 91 is not divisible by 5 or 3, so that is our answer. In simplest terms, that is. But that's how we will be multiplying fractions. You can either multiply them straight across and then simplify, or you can use the cross-canceling method first to simplify and to get into simplest terms, and then multiply across. I prefer cross-canceling because it makes you deal with smaller numbers. And dealing with smaller numbers is always nice. But now we will move on to dividing fractions. And so to divide fractions, let me go ahead and write that down, dividing fractions. To divide fractions, we're going to use a concept called the reciprocal. Now, the reciprocal involves flipping the second fraction and turning the operation that we're doing into multiplication. I'm going to show you what I mean by that. So, in our example, we'll have 5 over 12 divided by 3/4. Okay. And so, when we're working with fractions, it's actually really hard to divide two fractions. So what the mathematicians did is they basically used this concept of the reciprocal, and we'll keep the same fraction, the same first fraction. We'll have 5/12, but then our division will turn into multiplication, and our second fraction will be flipped to where the denominator is now the numerator, and vice versa. So we'll be left with 4/3. And then after that, we just multiply straight across. Now, in this case, since we're now to multiplication, I'm going to use cross-canceling. So I'm going to have 5/12. 12 can be written as 2 times 2 times 3. And then 4 can be written as 2 times 2. And then I have the 3 on the bottom. Since I have these 2's in the bottom and 2 2's in the top, they can cancel out. And I am left with 5 on the top, because this is technically a hidden 1 here. Now, this is a hidden 1, and this is a hidden 1. So I am left with 5 times 1, which gets me to 5, and then 3 times 3 gets me to 9. So my answer is 5/9. Okay. I'm not going to go into exactly how they found the reciprocal. You don't really need to know that for either Algebra 1 or Algebra 2, but you just need to know how to use the reciprocal. I mean, if you really want to know why it exists, you can look it up on Wikipedia or in another math textbook. But for right now, you don't really need to know how it works. You need to know how it works. You don't need to know why it works. Okay, so now we're going to move on to adding fractions. Now, adding and subtracting fractions takes quite a bit more work than multiplying and dividing. And so bear with me here, but adding and subtracting fractions is going to be a little bit longer than you would think. Okay. So when it comes to adding fractions, we have two different possibilities. One in which the two fractions we're working with have the same denominator, and then another one in which they have a different denominator. So, for example, if I have... Actually, you know what? I'm going to replace this. I'm actually going to do adding and subtracting fractions together, since they're somewhat similar. But it's still going to be quite long. So we'll have adding and subtracting fractions. Okay. So if I start off with an example and I have 7 over 15, and I'm adding 4 over 15, adding these two fractions is really easy. You're going to keep the same denominator, so we're going to have 15 on the bottom, and then you're just going to add the numerators together. So we're just going to add the 7 and the 4 together, and we get 11. And that's adding fractions if they have the same denominator. Additionally, if I'm subtracting fractions, and I have 6/10 minus 3/10, same thing applies. Since they have the same denominator, we keep the 10. And then 6 minus 3 is 3. And that's our fraction. That's our answer. However, everything changes if they have different denominators. So let's look at an example like that. We'll actually look at, I think, 2 or 3 examples. So, if the denominators are different, so let's write that down. When the denominators are different, what do? We use the LCM. The LCM stands for lowest common multiple. I'm going to show you how we use that now. So I'm going to have an example here where I'm going to have 3/10, and I'm going to add 5/8, or 5/8 to it. Now, since they have different denominators, they're different fractions of a whole, and it makes it really hard to add them together, especially when they're not of like terms. So what we're going to do is we're going to force these denominators to be the same. And what that means is we need to find the lowest common multiple between 10 and 8. The easiest way to do that is to take our two denominators, 10 and 8, and find the prime factorization of both of them. We'll start by doing that, and then we will basically combine the prime factors that they have in common. Okay, so if we have 10 and 8, I'm just going to write this in green. 10 as a prime factorization is 2 times 5. And then 8 as a prime factorization is 2 times 2 times 2. Now, in order to find the lowest common multiple, we need to take the most factors from each number. Now, in this case, 8 has more 2's than 10, so we're going to take the 3 2's from 8. However, 10 has 1 5, whereas 8 has no 5's. So we're going to take the 1 5 from 10. And so then, our lowest common multiple, our LCM, is going to be 2 times 2 times 2 times 5. And so putting that all together, 2 times 2 times 2 times 5 is 40. So our lowest common multiple is 40. So now what we need to do is we need to figure out what number do we multiply 10 by to get to 40, and what number do we multiply 8 by to get to 40. So 10 times what number makes 40, and then 8 times what number makes 40. I'm going to use orange for this. 10 times 4 gets us to 40, and 8 times 5 gets us to 40. Now these two numbers are going to be very important, because when we go back to our original fractions, we're going to multiply the top and bottom by these two numbers, 4 and 5. And then we will be able to add our fractions and get our answer. I know, it's very confusing. A lot of fun. Not. So we have 3 over 10 plus 5 over 8. And in this case, we need to multiply 3 over 10 by 4 top and bottom. And we need to multiply 5 over 8 by 5 top and bottom. And so we will be left with, for our first fraction, we'll be left with 12 over 40. And then for our second fraction, we'll have 25 over 40. And now, since they have the same denominator, we can now add them together, like we did at the very beginning of the adding and subtracting fractions section. So 12 plus 25 gets us to 37, and our denominator is 40. And that is our answer. Okay. I know lowest common multiple can be very confusing, so we're going to do one more example, and then in the next video we'll have even more examples. And I think to understand lowest common multiple, it really is just practice makes perfect. The more practice you do, the more you'll understand it. So let's go ahead and get another problem here. So we will have 12 over 20 minus, this time we'll subtract 5 over 12. Now, in this case, we need to find the lowest common multiple of 12 and 20. So we're going to first find the prime factorization of these two denominators. So we'll have 20, and we'll have 12. I use the colons, although you can use any symbol you want to separate the prime factorization from the numbers themselves. 20 is 2 times 2 times 5, right? 2 times 2 is 4, 4 times 5 is 20. And then 12 is 2 times 2 times 3. Okay. So then in this case, running out of room here, our lowest common multiple is going to be what exactly? So 20 and 12, they both have two 2's. So I'm going to take two 2's and add that to my lowest common multiple. And then 20 has 1 5, so I'm going to add the 1 5. And then 12 has 1 3. So I'm going to add the 1 3. Now, if your numerator on top of 20, for example, let's say had 2 3's, but 12 only had 1 3, then you would take the 2 3's. But we'll have more examples in the next video. But for right now, we're going to have 2 times 2 times 5 times 3. And so in this case, our lowest common multiple becomes 2 times 2 is 4, times 5 is 20, times 3 is 60. So we get 60. Okay. That's the number we need to find. That's the number we need to get to. So if we look back at our original fraction, we had 12 over 20 and 5 over 12. So we need to figure out what do we multiply 20 by to get to 60? And then what do we multiply 12 by to get to 60? 20 times what gets to 60? That would be 3. And then 12 times 5 gets us to 60. Okay, so those are the two numbers we need to multiply by. So we're going to have 12 over 20 minus, can I give myself a little bit of room, 5 over 12. For 20, we have to multiply top and bottom by 3. And then for 5 over 12, we need to multiply top and bottom by 5. And now we will be left with 36 over 60. And in our second fraction, we'll have 25 over 60. And now, since they have the same denominator, we can subtract them together. 36 minus 25 is 11. 60 remains the same. And that is our answer. Okay. So, a little bit of a recap. We went over multiplying and dividing fractions, and then we went over adding and subtracting fractions. Multiplying and dividing fractions I think is much easier than adding and subtracting. Adding and subtracting requires using the lowest common multiple, which we'll get to in the next video. We'll have more examples where I'm going to give you a set of examples of multiplying, dividing, adding, and subtracting fractions. So I think the more you see it, the more you're exposed to the lowest common multiple, the more it will make sense. But for right now, that is this video.